Hello, welcome to ML Agents in Unity. I'm Tyler, and I'm going to go through quickly, briefly, show you guys how ML agents work in Unity with a few scenes from a project you can download from GitHub. It gives you a whole bunch of different scenes to view through and check out to understand how ML agents work with reinforcement learning. Um, Unfortunately, today, I can't run any of these because I have a bunch of compile errors and I need to sort out. But I'm going to explain to you how the system would work. How these little guys here will complete their goal. I'm going to be looking at three scenes that I thought I liked the most and thought were the coolest. And I'm just going to explain how everything works with ML machine learning is what ML stands for, machine learning agents in Unity. I assume you guys are here to learn the same thing, get a better understanding of how that works, and hopefully, by the end of this video, you guys have a pretty good grasp on how everything works. And you too can download this project from GitHub, and then just import it into a empty project, and it gives you a bunch of different stuff right off the bat. So let's get started. In this first scene, when you go into the ML Agents folder and examples, and you have a bunch of different scenarios that you can kind of go through. So what I'm on is Dungeon Escape. But judging by the name, these three guys, because if we look at this guy here, it's obviously a dragon. So these three guys are going to need to get to that door. And I assume this key right here needs to open that door. All right. So with ML agents, these guys aren't going to know right off the bat what they need to do. There's a lot of programming involved and setting up to the point where they will eventually get this key and go to that door flawlessly. But right out of the gate, that's not going to happen. So what these that you're seeing right here are just lights. So this is just kind of adding effects to the arena area. So these aren't really special in any way. They're just showing you that this is light. So you got a dragon, and I assume the dragon moves around too. What's interesting is if the dragon is an agent, he too will get better. He or she too will get better at catching these guys. So I assume these guys have 3 chances to get out of here. 1, 2, 3. If the dragon catches one, it disappears and dies. And if the guys can get the key, they will go to the door and escape. Now, I don't know how basic this is right out of the gate with this level, but what will happen is if I were to play this, these guys will wander around the playing field until they hit the key. Once they hit this key and come in contact with it, a little reward, if you will, triggers inside of them, showing them that that's the way. This is the correct move right here. But with the dragon, I assume once it comes in contact with a player and destroys them, that will be its reward, knowing that it did the right thing and knows what to look for. So once you play this the first time, the dragon will probably wander around, these guys will wander around, and eventually one of them will bump into this key, triggers a reward in their system, knowing that this is the right move. Dragon will wander around until it runs into one of these guys, triggers the reward, and it knows what it's looking for. It has a better idea of what it's looking for and how to accomplish that better than before. Once they get this key, they'll probably continue wandering around until they come across the door, and that will end the game. And that will be a reward factor for them. So they know that, okay, next time we play this, after what we just learned, we need to get this key and go to this door. And at some point, these guys will learn that this is something bad and trying to avoid that as well. So once one of these guys gets swallowed up by the dragon, I'm sure there'll be like a consequence in their system that'll tell them stay away from this object on the board. So the more times you play this, the more they will learn and get better at succeeding and avoiding the dragon. But at the same time, the dragon will also, over time, get better. So at first, the very first playthrough, they're going to be wandering around like crazy, not knowing exactly what they're doing until they finally figure it out. Probably, and it depends on how fast they learn and how fast they go with this. I've seen some tutorials where, they pick it up pretty quickly, but sometimes after the second run, they won't know right to just go right for the key, and they'll kind of like hesitate a bit. They'll definitely be better than they were before. Instead of just wandering around, they might move towards this direction because they know it's in this direction, and then run into the key, and then they'll know that this door is in this general direction, so they'll probably start heading in this general direction towards the door. But probably after 10, maybe 15 playthroughs, you'll definitely notice a huge difference in their learning and solving this puzzle. Right out of the gate, you'll probably have one of these guys go straight for the key. At some point, that's basically how it's going to go. You play, they're going to go right for the key, grab the key, and go right for the door. Potentially, at that level, the dragon will know what it's looking for too. So it'll obviously probably go right for them instead of just wandering around. So by the time this is all said and done and they've learned as much as they can, they'll go right for the key, make their way around the outside probably because the dragon will be coming up the middle for them, and then loop around and get to the door. They can still... I mean, I don't think there's a limit on ML agents with how much they can learn. They could still learn from even a successful scenario like that, grabbing the key, running for the door. I mean, it might take them shorter amount of time to do it. They might get faster. I don't know. But that's the general basis of how ML agents work. They get a reward for doing the right thing. So next time you play it, they know to do that exact thing again to get another reward until they basically accomplish their task. Let's look at another example. So we've got, what one? Match 3. This one looked a little simple, but with Match 3, you basically got this giant board. And I assume once you play it, if it worked, it will show you a bunch of pictures, and the AI in this scenario, which isn't, obviously it's not a block, it's probably just a selecting agent. That's what I'm assuming it is. I don't see it in here, but I assume it's just a AI agent that selects the options that are shown to it. So when they show these pictures in this grid, the AI agent's going to choose pictures and try and match them up. Whenever it gets a right matchup, it's going to trigger a reward in its system, telling them that you got that right, that was the right move, and it will remember, or slightly remember at least for the first few times, which pictures match, until it basically fills out this whole grid and matches everything. So the first few times you play this, it'll probably make a bunch of mistakes trying to match pictures, but at the end of it all, once the AI has learned quite a bit, it'll probably run through the board like nothing and match every single picture on the first try. That's the beauty of artificial intelligence and reinforcement learning. The reinforcement part is giving an AI the reward aspect in its system, telling it that it's doing the right thing, and to continually repeat that over and over and over again until it becomes flawless in its execution. Let's look at one more example. There was soccer. So for this soccer, we've got a field with 2 AI units, each on each team, and a soccer ball right in the middle. Now, what I've said before, odds are when you play this for the first time, these guys are going to wander around not doing too much until one of them pushes the ball into the goal. And when that happens, it'll trigger a reward for that team, so they know that they're doing the right thing. They know that that's what the goal is, to get the ball into the goal. Now this is a bit tricky because if one team, the first team that gets it in the goal, will know what to do, so they'll have a better chance of completing it the second time over the other team that didn't get it. So if there's one team that just keeps on sinking this goal over and over again, they'll get better and better and better, whereas the other team will just continually wander around. I'm not entirely sure on how this will work. I mean, I guess you could say the opposing team that continually loses would get kind of like a consequence in their system, telling them that you got to avoid that type of situation going forward. The ideal scenario with this machine learning here is each team goes back and forth scoring the goal and gets better over time to the point where this is actually a really good competition between these AI units. One team scores, gets a reward knowing that they got to do that. The purple team scores, gets a reward knowing that they got to continually do that, and it just keeps on going back and forth while each team learns equally and becomes better. And in the perfect scenario, once these guys have gotten quite a bit of knowledge on what to do and what not to do, right out of the gate, they'll go for the ball, try and get it into the other team's goal, and there'll probably be a lot of fighting and pushing the ball around and trying to win. But that's AI. They're learning to do better, and I would hate to see it kind of get wasted with one team winning over and over and over again and advancing, whereas the other team just kind of like gets stuck and just keeps on wandering the field, wondering what its reward is. But I could definitely dive deeper into this type of scenario, but this one's kind of tricky and interesting. But that's basically how it would turn out in the perfect scenario. They would just right out of the gate get the ball and try and get it in the goal. But that is the ML agents for Unity. That's a general understanding of how they work. There's a lot of programming that goes into that. But in this video, we're just talking about how it works in general and what you can expect when you run these scenarios.